For millions of years before humans looked anything like the creatures we recognize today, our ancestors moved through the ancient African landscape wrapped in a thick coat of fur. It wasn't decoration. It wasn't luxury. It was a life support system, one that had protected primates for tens of millions of years. Under the cool shadows of the forest canopy, fur trapped warmth during cold nights, shed rainwater during storms, softened the bite of insects, and cushioned the body against the rough world around them. In those days, a primate without fur would have seemed as strange as a bird without feathers. The air in those forests was heavy, warm, and buzzing with insects. Early hominins clung to branches, plucked fruit, dug for roots, and carried infants against their furred chests. Their world was green and layered, a maze of leaves and shadows where sunlight barely reached the forest floor. Here, a thick coat made sense. Nights could be surprisingly cold. Rain fell in violent curtains. Predators prowled in silence. Fur was armor, insulation, protection, and evolution had perfected it over millions of years. But the world was already changing in ways no creature could understand. Climate cycles shifted. Rainfall patterns broke apart. Seasons stretched longer and swung harder. Forests slowly retracted, splitting into scattered islands of trees separated by rivers of grassland. Where there had once been endless shade and moisture, now lay open plains that baked under a brutal sun. For the first time, early hominins were forced to navigate a world where their greatest evolutionary advantage, thick fur, began turning into a deadly disadvantage. Imagine one of these furred ancestors standing at the edge of a thinning forest, staring across a shimmering savanna at midday. The air above the grass ripples with visible heat. A single step forward pushes him into an environment his body was never designed for. The sun pounds down on his fur, trapping heat that cannot escape. His skin begins to warm dangerously. His heartbeat accelerates. In just a few minutes, exhaustion threatens to collapse him. And yet, beyond this scorching plain lie water, food, and all the resources necessary for survival. At first, only the boldest individuals ventured out for short distances, but droughts, shifting rivers, and shrinking forests forced entire groups to follow. Day after day, generation after generation, these furred hominins pushed farther into deadly heat. This was when tiny biological differences too small to notice in a single lifetime, began shaping the fate of our species. An individual with slightly less fur could walk a little longer before overheating. Another with more functional sweat glands cooled just a bit faster. Those who could endure the sun survived more dry seasons, found more food, protected their young longer, and passed on their traits. But heat wasn't the only new threat. The open plains were alive with parasites, ticks, fleas, lice, biting flies, creatures that thrived in heat and dryness. A dense coat of fur became a perfect home for them. Each strand offered a hiding place. Each warm patch of skin became a breeding ground. And because hominins began living in larger groups, sleeping on open ground and reusing the same shelters, parasites spread faster than ever. A single infested individual could infect an entire band within days. Suddenly, the protective coat that had ruled primate evolution for millions of years became a liability. Bare skin healed faster. Fewer hairs meant fewer hiding spots for insects. Individuals with thinner coats found themselves suffering fewer infections and recovering from wounds more easily. Step by step, generation by generation, natural selection began carving fur away from the human body, not evenly, but strategically. Hair remained thick where it still served a purpose, on the head to shield the brain from the savage sun. It stayed in intimate areas where scent and friction mattered. But across the torso, limbs, and back, The dense coat slowly retreated. Our ancestors didn't know change was happening. They didn't understand evolution. They didn't see themselves becoming different. But nature was already reshaping them into creatures built for a world beyond the forest, a world of heat, distance, danger, and movement. And from the moment they stepped onto the savanna, the transformation had begun. As the savanna tightened its grip on early humans, the gradual thinning of fur was only the surface of a much deeper transformation. Beneath that changing skin, the body was being redesigned for a new kind of life, one defined by heat, distance, and constant movement. Every step across the plains produced internal heat. Muscles burned, the heart raced, and the sun pressed down relentlessly. Animals with thick fur could not survive long exertion here. Most mammals cooled themselves by panting, but panting collapses the moment an animal must run for hours instead of minutes. Early humans, however, were becoming something different. They didn't sprint like cheetahs or leap like gazelles. Their greatest strength was persistence, the ability to keep moving long after other creatures had reached their limits. But persistence required a better cooling system, something that worked even while running. And so, generation by generation, eccrine sweat glands multiplied across their bodies. Each tiny pore was a vent, releasing heat directly through evaporating moisture. The less fur an individual had, the more effective this cooling became. For the first time in primate history, the entire skin surface became a tool, an enormous, efficient radiator that allowed early humans to stay active under conditions that would overwhelm almost any other mammal. This new ability opened possibilities no furred animal could match. Imagine a group of early humans moving at a steady trot under the midday sun. Predators slept in the shade. Hoofed animals panted desperately, overheating after short bursts. But these early humans kept advancing step by step, hour after hour. They did not need speed to hunt. They needed endurance. And bare, sweating skin made endurance possible. A chase that lasted half a day could bring down prey larger and faster than themselves, not through force, but through patience and heat tolerance. This alone gave our ancestors access to richer food sources, meat, fat, and marrow that fueled growing brains and expanding bodies. But heat was only part of the story. As humans moved farther from forests, parasites remained a constant danger. Dense fur offered perfect shelter for fleas, ticks, and flies, and in open campsites they multiplied rapidly. Bare skin, however, exposed parasites immediately. A bite, a tick, a louse, nothing could hide as easily. Individuals with thinner hair suffered fewer infections and recovered faster. Grooming became easier and more social. Touch, once mainly for cleaning fur, now deepened bonds, calmed conflicts, and strengthened group cohesion. Meanwhile, firelight reshaped the nights. Before fire, thick fur had been essential for warmth, especially when sleeping away from trees. But once early humans learned to maintain glowing embers through the evening, warmth no longer depended entirely on the body. Fire acted like an external coat, keeping the cold away, deterring predators, and allowing groups to settle in places previously impossible. Infants could survive with less natural insulation if kept close to warmth. Adults no longer risked freezing without dense fur. Fire weakened the evolutionary need for heavy body hair, pushing the process of hair loss even faster. With these changes combined, long-distance movement, parasite pressure, fire for warmth, and constant exposure to open landscapes, bare skin gradually shifted from an accidental advantage to a defining feature. Not only did it keep early humans alive, but it began shaping how they interacted with each other. Without fur, emotions appeared on the surface: blushes, fear, anger, confidence. Skin became a canvas for communication, subtly influencing the social world long before language fully formed. By the time these transformations reached stability, Early humans were no longer creatures of the forest. Their bodies were adapted to heat, distance, and endurance. Their skin had become their greatest survival tool. And though they couldn't have known it, the path toward becoming the naked ape had already been set in motion. When early humans first stepped fully into the blazing world of the savanna, they encountered a challenge no primate before them had ever faced: surviving hours of movement under an equatorial sun. Heat was everywhere, radiating from the ground, pouring from the sky, rising from their own bodies as they walked and tracked animals over long distances. Every living creature around them had a strategy for managing that heat. Most relied on fur for insulation and panting to shed excess warmth. But these strategies collapsed the moment endurance became essential. Panting interfered with breathing during long runs, and heavy fur trapped more heat than it released. Evolution began searching for another solution. The body already possessed a primitive system: eccrine sweat glands scattered across the skin. In forest environments, these glands played a small role, mainly for grip or mild cooling in patches where fur was thin. But on the open plains, this overlooked feature suddenly became the key to survival. Individuals who produced more sweat could cool their core temperature faster, stay active longer, and avoid deadly overheating. Over hundreds of generations, eccrine glands multiplied until human skin held more of them than any other mammal of similar size. This shift didn't just cool the body, it changed the rules of endurance forever. Picture a small band of early humans beginning a pursuit under the midday sun. The air shimmers with heat. The prey bolts, sprinting hard, panting violently as its temperature skyrockets. But the humans don't sprint. They simply maintain a steady trot. Sweat evaporates along their limbs, chest, and back, pulling heat away continuously. After a few kilometers, the prey must stop to cool down. The humans keep coming. It sprints again, panics again, overheats again. Hour after hour, the cycle continues until the animal collapses, not because the humans were faster, but because they could stay cool while moving. This endurance-based lifestyle reshaped anatomy from the inside out. The torso lengthened to support powerful breathing. The Achilles tendon became a spring for long-distance strides. The arches of the feet transformed into shock absorbers. Even the shape of the skull changed, with expanded venous systems to cool the brain. And covering all of this was bare, sweat-rich skin. No fur to impede evaporation, no insulation trapping deadly heat. As sweating took over thermal regulation, body hair retreated even further. Any patch of dense fur became a liability, blocking airflow and trapping moisture. But hair didn't vanish everywhere. The head retained a thick covering to shield the brain from ultraviolet radiation while allowing heat to rise away from the skull. Eyebrows helped channel sweat away from the eyes. Hair in the armpits and groin captured scent molecules used in early social and reproductive signaling. Evolution didn't wipe the slate clean. It edited strategically, keeping only what still mattered. With improved cooling came new freedoms. Groups could travel farther from home bases, explore unfamiliar valleys, and follow migrating herds. Longer journeys exposed them to new foods: roots during droughts, shellfish along rivers, carcasses abandoned by predators. Endurance running allowed them to access meat before scavengers. The calories from this new diet helped fuel larger brains, which in turn demanded more precise temperature control. Bare skin and abundant sweat weren't just adaptations, they were prerequisites for the intellectual leap that would follow. Sweat also changed how humans experienced the environment. A breeze across exposed skin could cool them instantly. Rain felt sharper. Touch became more sensitive. Without fur, the world pressed directly against the body, and the body interpreted every sensation more clearly. As this new physiology solidified, early humans became creatures utterly unlike their ancestors who once moved through shaded forests. They were no longer limited by heat. They were no longer bound to the rhythm of panting or the restrictions of fur. Their bodies had become engines built to travel, to endure, to chase, and to explore. Bare skin had opened the door. Sweat pushed it wide. As early humans continued to master the art of surviving heat, endurance became more than a strategy. It became a defining feature of their existence. The transformation was so gradual no individual ever noticed it, yet the consequences reshaped every aspect of daily life. What began as a response to scorching sunlight evolved into a complete re-engineering of the human body, turning bare skin and sweat into tools as vital as stone blades or fire. Imagine the savannah at dawn. A small group rises from their sleeping ground, embers from the previous night still glowing faintly. They stretch stiff muscles, gather simple tools, and begin moving long before predators awaken. For them, timing is everything. Heat builds as the sun climbs, and they know that the hours between morning and early afternoon offer a window of opportunity no other creature dares to exploit. Their secret weapon isn't sharp teeth or crushing strength, it's the ability to stay cool when others can't. With every steady step, sweat beads across their skin. A faint breeze sweeps away heat as quickly as it forms. They move silently through dry grass, reading footprints, listening for distant hoofbeats, watching dust kicked up by frightened herds. When they identify a target, an antelope, a zebra, even a young buffalo, they begin the pursuit. The prey bolts, sprinting with explosive power, but power comes at a cost: overheating. Within minutes, its internal temperature rises dangerously. It pauses in the shade, panting desperately. But the humans arrive again, forcing it to run once more. The cycle repeats: run, pant, run, collapse. This method, persistence hunting, relied entirely on an evolutionary advantage no fur-bearing predator possessed. Bare skin turned endurance into a weapon. This lifestyle forced early humans to develop a new relationship with their environment. Water became precious, not only to drink, but to cool the body. A small pool or shaded stream was more than a resource. It was a sanctuary during long pursuits. Knowledge of where water lay, how far it was, and when it might dry up became essential survival intelligence. Bare skin, for all its cooling ability, also evaporated moisture quickly, meaning dehydration was a constant risk. Those who could balance stamina with hydration passed their genes forward. As the years inched by, sweat and hairlessness began shaping culture as much as biology. Campsites formed near water sources. Division of labor emerged naturally. Some individuals tracked prey, others prepared shelters or guarded young. Cooperation deepened because endurance hunts demanded teamwork. One runner might follow prey for hours while another carried tools or observed from a distance to predict the animal's next move. This level of coordination strengthened bonds, and bare skin played a subtle but important role. Without fur, changes in emotion, fear, confidence, anger, exhaustion, became visible on the surface. A flushed face warned of overheating. Pale skin signaled shock or dehydration. Sweat patterns revealed exertion. Even before language matured, skin helped communicate without words. Hairlessness also amplified the importance of touch. Grooming, once a practical necessity for removing parasites, evolved into a tool for bonding. With less fur, touch went from pulling hairs to soothing skin. Fingers brushed against shoulders, backs, and arms, reinforcing trust within the group. Emotional comfort became tied to physical contact, something still evident in humans today. Bare skin did more than cool the body. It strengthened social fabric. As endurance became central to survival, The bones and muscles of the legs and spine adapted to sustain longer strides. Wide hips balanced the torso during running. Strong gluteal muscles stabilized each footfall. Even the position of the head shifted so the eyes could level with the horizon while the body moved. Sweating didn't just interact with these anatomical changes, it made them possible. A furred animal could not maintain the pace needed for such distances, but a human, shedding heat with every step, could keep going until the world opened before them. This new mobility had ripple effects across behavior. Groups could relocate quickly when food ran low. They could cross open plains to reach distant watering holes before predators. They could follow migrating herds for weeks. Movement became freedom, and with freedom came expansion, out of forests, across savannas, toward rivers, lakes, and eventually across continents. In this era, fur had lost its place in the human toolkit. Bare skin was now the superior design. It allowed sweat to flow unimpeded. It freed the body to travel further and longer than any primate before them. It blended with fire, tools, and group coordination to unlock new possibilities that would change the fate of our species. By the time early humans mastered endurance hunting, the idea of thick fur covering their bodies had become a relic of deep evolutionary memory. They were no longer primates shaped by forests, but pioneers shaped by heat, distance, and the open sky. Creatures whose very survival depended on sweating, moving, and staying cool. And because of this, the story of how humans lost their fur was only just beginning. As early humans adapted to endurance and heat, another invisible force was shaping their bodies just as powerfully as the sun: parasites. On the open savanna, every tuft of fur became a miniature ecosystem for creatures that fed, burrowed, bred, and spread disease. Where the forest once provided shade and humidity, the plains offered new kinds of threats, tiny but relentless enemies that could weaken an entire community from the inside out. The moment early humans began sleeping on the ground instead of in trees, parasites multiplied. Fleas hid in grasses and crawled into bedding sites. Ticks waited on shrubs for warm bodies to brush past. Blood-sucking flies swarmed around campsites drawn by sweat, leftover scraps, and the scent of prey. Dense fur, once a shield in the forest, now held on to pests like a sponge. A single tick bite could infect the bloodstream. A cluster of fleas could drain energy from an infant, and infections spread quickly through groups that slept, huddled, and groomed together. Evolution doesn't play favorites. It favors survival. And in this new world of parasites, individuals with thinner hair had a subtle yet crucial advantage. Bare skin exposed invaders. A tick crawling across a shoulder was easy to see and remove. A flea attempting to burrow was quickly spotted. A biting fly found fewer places to hide. Over time, these small advantages added up. Groups with less fur endured fewer outbreaks, suffered fewer skin diseases, and spent less energy fighting off infections. As hair thinned, grooming, already an important behavior among primates, took on a new meaning. Grooming was no longer simply about maintaining fur. It became essential for health, hygiene, and social stability. Without thick hair hiding parasites, individuals could spot and remove threats far more efficiently. Fingers brushed across shoulders, backs, arms, and legs. A quick touch could detect a tick or louse. A gentle scratch could remove it. This increased the importance of touch within the group. Grooming didn't just protect the body, it strengthened emotional bonds. Each act of careful attention built trust, calmed tension, and reaffirmed belonging. Campsites revealed another issue. Parasites did not simply live on bodies, they lived in the environment. Early humans often returned to the same sleeping spots, leaving behind fur, skin flakes, food scraps, and warmth that attracted more pests each night. Thick-coated animals would have brought these parasites back into their fur, allowing them to hide and multiply. But humans with bare skin didn't give them many places to attach. Their smooth bodies forced parasites onto the surface where they could be removed or killed. Bare skin, in this way, acted as a simple but effective defense. It limited the private spaces where pests could hide. It made any infestation visible. And because parasites thrive in fur, not on exposed skin, losing hair dramatically reduced their survival. Parasites shaped more than biology. They shaped culture. Early humans learned to choose cleaner resting areas. They used smoke to drive insects away. They learned to avoid tall grasses or damp shelters where pests gathered. Fire, which already provided warmth and protection, helped burn insect nests and sterilize campsites. Over time, this reduced the reliance on fur even further. The cleaner and safer their sleeping sites became, the less they needed insulation from the environment. Disease pressures also played a silent role. Infections carried by ticks and fleas could spread rapidly and become deadly. Groups that avoided these outbreaks survived longer and raised more offspring. Bare-skinned individuals, suffering fewer infestations, passed their genes forward. Slowly, the balance of evolution tipped away from thick fur toward a smooth, hair-light covering. This process didn't happen in a few generations. It happened over hundreds of thousands of years. But its effects were unmistakable. Losing fur wasn't just about heat. It was about survival in a world full of microscopic threats. And while the savanna reshaped the outside of the human body, parasites were changing it from within, removing the last evolutionary logic behind keeping a heavy coat. The next stage of this transformation would come from yet another force, fire, changing not just how humans survived, but how they slept, lived, and defended themselves from the night. As the struggle against parasites intensified, early humans continued to evolve in ways that made thick fur not only unnecessary but actively harmful. Parasites didn't just irritate, they weakened, infected, and threatened survival. On the savanna, these creatures flourished in ways far more aggressive than in the forest ecosystems our ancestors once knew. And every generation that passed through this harsh world carried a little less fur, a little smoother skin, and a body slightly better equipped for the endless battle against the tiny enemies that fed on them. Sleeping on the ground created the first major shift. Without the elevated safety of branches, early humans rested directly on earth that crawled with larvae, beetles, mites, and insects emerging at night. A thick coat offered parasites thousands of warm hiding spots. Bare skin, on the other hand, presented nowhere to cling for long. A single scratch or swipe could remove most invaders. Even infants, the most vulnerable members of the group, benefited when their mothers had smoother skin. Fewer parasites meant fewer infections passed to their offspring. As body hair thinned, a new behavior emerged: precision grooming. Instead of digging through dense fur for pests, individuals began scanning one another's exposed skin, using fingertips to detect even the faintest movement or irritation. Grooming became more intimate, focused, and emotionally significant. A hand running along the arm was both a health check and a reassurance, an unspoken statement that said, "You belong to this group. You are cared for." Over time, this transformed grooming from a practical necessity into a cornerstone of early human bonding. Parasites also influenced where early humans chose to settle. They learned which types of grass harbored ticks, which muddy banks swarmed with biting flies, and which shelters accumulated pests. Groups that understood these patterns avoided infested areas and selected cleaner, windier, or drier locations where pests couldn't thrive. Bare skin made this learning impossible to ignore. Every wrong choice left marks on their bodies. In a way, human skin became a map of ecological knowledge, teaching each generation where danger lived. Fire accelerated this transformation even further. A burning branch scattered insects. Smoke drove mosquitoes away. Embers sterilized the ground. The moment early humans began sleeping near fire, parasites lost access to the safe, humid, shaded environment they preferred. Fur was no longer needed as insulation at night, freeing the body to evolve towards smoother skin without risking cold exposure. With fire, the balance between humans and parasites shifted dramatically. Thick fur no longer protected. It became a liability, trapping pests that fire had not driven off. But parasites didn't only shape biology and behavior, they influenced social structure. Because skin was exposed, individuals could visually detect infection, injury, or disease on others. Sick members of the group were noticed quickly. The appearance of boils, rash, swelling, or wound infection was no longer hidden beneath dense hair. This visibility encouraged care, helping another clean a wound or remove a parasite, strengthening cooperation. It also taught early humans to avoid individuals with signs of disease during outbreaks. Bare skin made health a shared responsibility. As the evolutionary tug-of-war continued, nature removed any advantage thick fur once offered. Without forests, fur no longer insulated against cold. Without trees, it no longer softened the scrape of branches. Without solitude, it no longer hid parasites. On open plains filled with heat and insects, bare skin proved the superior design. Over thousands of generations, hair retreated more and more, its absence becoming the norm rather than the exception. By the time this long battle began to stabilize, the human body had been transformed. The once furry primate of the ancient forests had become a creature shaped by sunlight, long-distance travel, fire, and a constant war against parasites. Hair clung only to areas where evolution demanded it, on the head for protection, around the eyes to deflect sweat, and in regions where scent communication or friction played roles. The loss of fur was not random. It was strategic, sculpted by millions of years of pressure from the natural world. Parasites were only one piece of the puzzle, but without their influence, humans might never have shed their ancient coat. Soon, another force would enter the story, one just as transformative as parasites and heat. Fire, culture, and the beginnings of clothing. These would reshape human bodies in ways that made hairlessness not just an adaptation, but a defining feature of our species. Long before fire became a symbol of human mastery, it was simply a fragile glow in the darkness, something early humans feared, approached cautiously, and only gradually learned to control. But once they did, the course of human evolution changed forever. Fire didn't just warm their nights, it rewrote the rules of survival. And in doing so, it accelerated the loss of fur more powerfully than any force before it. Imagine a small band of early humans gathered at dusk. The savanna cools quickly and predators begin to stir. Lions stretch in the distance, hyenas emerge from their dens, jackals circle silently. Without fire, these hours were once the most dangerous of the day. Early humans would have needed thick fur to stay warm through long, exposed nights. They would have climbed trees for safety or huddled in crevices, trembling at every distant roar. But with fire, the balance shifted. A ring of orange light pushed back the night. Sparks rose upward like tiny stars. The warmth radiating from the flames allowed early humans to stay comfortable, even without dense fur. Predators approached, but kept their distance, confused or intimidated by the strange illumination. For the first time, humans could sleep on open ground without relying on their bodies to provide insulation. Fire became an external coat, one that did not need to be grown, groomed, or carried. As fire took over the role of warmth, the evolutionary pressure to maintain a thick coat weakened dramatically. Adults with thinner fur no longer suffered through cold nights. Infants who would once have died without heavy insulation now survived if held near the fire or wrapped in early improvised coverings. Fire didn't just make life easier. It opened the door for the human body to shed fur without fear. Nights around the fire also reshaped social life. The circle of light became a gathering place where the group shared food, protected one another, and communicated. Without fur, skin reflected firelight, making it easier to read expressions. The subtle movements of faces, frowns, smiles, fear, calm, became more visible. Emotional communication deepened long before language reached full complexity. Skin, no longer hidden beneath fur, began to play a central role in social interaction. Fire introduced humans to rhythm, storytelling, and memory. The hours after dark were no longer dominated by fear, but filled with calm and presence. Elders spoke, children mimicked sounds, adults planned hunts. Flames cast shadows on bare skin, highlighting gestures and movements. Over time, this nightly gathering strengthened group identity. But fire did more than warm bodies and illuminate faces. It changed how humans ate. Cooked food required less chewing and less digestive energy. Meat softened, roots became edible, toxins in plants were neutralized. This shift in diet supported larger brains and reduced the need for massive jaws. A smaller mouth and more expressive face meant more exposed skin and less fur to conceal emotion. Fire also interacted with parasites. Smoke drove mosquitoes away. Flames burned nests hidden in grass. Ash rubbed on the skin deterred insects. Bare skin, more exposed to the environment, paired perfectly with fire's protective properties. Together, they formed a barrier far stronger than fur had ever been in the heat and humidity of the plains. As humans learned to carry fire from place to place, often using smoldering branches or embers wrapped in leaves, the world opened even more. They could move into colder valleys and open hilltops without relying on fur to keep warm. Fire encouraged exploration, and exploration rewarded bodies that could adapt quickly. Without the burden of heavy fur, humans moved light and fast across vast territories. The influence of fire didn't stop at warmth or protection. It laid the foundation for a new kind of shelter. With flames to guard the night, early humans began constructing semi-permanent sleeping areas, circles of stones, pits, overhangs, and windbreaks. These shelters trapped heat, creating stable microclimates. A warm shelter meant a body with little fur could survive through conditions that would have once demanded a thick coat. Each generation spent more time around fire. Each generation needed less natural insulation. And so fur continued its slow retreat. By now, loss of hair was no longer merely a response to heat, parasites, or endurance. It had become intertwined with culture itself, an adaptation that worked because humans were learning to survive not just with biology, but with tools, knowledge, and cooperation. And the next tool they would invent, one that replaced fur entirely, was clothing. As fire reshaped the rhythm of human life, another quiet transformation began to unfold, one that would permanently eliminate the last evolutionary need for fur. This transformation wasn't biological at first. It was cultural. It was the invention of simple coverings, the earliest forms of clothing, long before humans ever understood stitching, weaving, or tailoring. These primitive garments changed the destiny of our species just as powerfully as fire, endurance, and parasites had. Imagine the earliest coverings, not crafted fashion, but necessity. Strips of hide pulled from an animal carcass, large leaves bound with vines, bark softened by pounding. None of it was elegant, but all of it was useful. A piece of hide draped over shoulders protected against cold winds. A wrap of plant fiber shielded tender skin from thorns and rough ground. Even the simplest coverings eased the burden that fur had once carried. Fire had already weakened the need for a natural coat, and these primitive clothes pushed evolution even further. Now, insulation could be added or removed at will. A group could move into colder regions and survive by wrapping themselves in hides instead of relying on thick fur year-round. Infants could be bundled and carried, no longer dependent on their mother's body hair for warmth. As these coverings became more common, the evolutionary pressure to maintain fur dropped sharply. A body with sparse hair was no longer vulnerable. It was increasingly efficient. Clothing didn't just protect the body. It changed how humans understood their environment. They learned which materials irritated the skin, which softened with age, which resisted insects, which held heat well. They discovered that certain plant fibers absorbed moisture or insulated during cold nights. With every experiment, fur became less relevant. Skin, once kept safe by a thick coat, now relied on human invention. As clothing became integrated into daily life, it influenced movement, sleep, and work. A simple hide wrap allowed humans to sit on rough stone, cross thorny ground, or venture into cold, early mornings without discomfort. These advantages encouraged exploration. Groups could settle near rivers with cold winds, near cliffs with sharp stone, or in open plains where nights chilled quickly. No longer tied to warm environments, humans expanded across wider territories. This expansion favored bodies that wasted less energy maintaining fur and invested more in muscles, endurance, and cognition. Bare skin also interacted in new ways with the world. Touch became more precise. Temperature changes were felt instantly. A cool breeze, a warm stone, even the texture of plants became sensory information. Fur had once muted these sensations, but hairless skin amplified them. This heightened sensitivity helped early humans detect danger, weather shifts, and environmental clues essential for survival. Over time, clothing took on roles beyond simple protection. It became a marker of identity, status, and season. A well-preserved hide might indicate hunting skill. A carefully wrapped infant showed maternal care. As tools improved, coverings became more refined, scraped, softened, shaped. Every refinement made natural fur less important. Evolution favors what works, and culture now provided what biology once had to supply. With shelters growing more complex, stone circles, windbreaks, caves lined with warmth, humans lived increasingly in controlled environments. Fire heated these shelters, clothing insulated the body, parasites were kept at bay. In this world, dense body hair offered no advantage. It trapped heat in warm seasons, harbored insects, and caused discomfort under coverings. A hairless body beneath a hide wrap was simply more efficient. The more humans relied on fire and clothing, the more biology surrendered its ancient roles. Nature tends not to maintain traits that cost more energy than they provide. Growing fur required calories. Repairing fur after injury used resources. But maintaining bare skin demanded almost nothing. And as the environment became shaped more by human hands than by the raw forces of nature, evolution allowed fur to fade quietly into the background. Still, hair never vanished completely. The head's thick covering remained, shielding the brain from harsh sunlight. Eyelashes and brows stayed to protect vision. Hair persisted in areas linked to scent and reproductive signals. But the rest of the body grew increasingly smooth, increasingly bare, increasingly adapted to a world that humans themselves were shaping. By now, hairlessness had become a partnership between biology and culture. Fire, movement, grooming, and clothing all woven into one evolutionary story. The naked ape was no accident. It was the result of countless generations discovering ways to survive not through fur, but through ingenuity. And soon, another force, one rooted in attraction, choice, and desire, would shape the human body just as strongly as climate and parasites had. Long after endurance, heat, parasites, fire, and early clothing had already begun reshaping the human body, another force quietly entered the evolutionary story, one far more subtle, yet capable of altering a species just as dramatically as climate or predators. This force was attraction. Not survival in the strict sense, but choice. The choices individuals made about whom they lived with, cared for, and reproduced with. Sexual selection. Humans were no longer just surviving the environment, they were surviving each other's preferences. As fur thinned and more skin became visible, early humans began noticing things they had never seen so clearly before. The flush of emotion across a cheek, the sheen of sweat on a shoulder, the rhythm of breath rising and falling against exposed ribs. Without fur, bodies communicated health and vitality openly. Skin became a social language long before words fully existed. Imagine a group gathered around a fire. In the glow, bare skin reflects warmth and movement. A healthy individual has smooth, unblemished skin, free from parasites, infection, and disease. Their posture is relaxed, their breathing steady. Another, struggling with illness or injury, shows it immediately. Inflammation, rashes, pallor, or tremors. These signals mattered. In the animal kingdom, fur often hides weaknesses. In early humans, bare skin revealed everything. Over generations, these visual cues began guiding mate choice. Individuals naturally gravitated toward partners whose exposed skin signaled good health. Those with clear, vibrant skin appeared more resistant to disease and parasites. Those with stronger circulation flushed easily, showing vitality. Those with smooth skin showed fewer signs of stress or chronic infection. Even subtle differences, firmness of muscle beneath the skin, symmetry of features, the sheen of sweat indicating good hydration, began influencing attraction. Sexual selection works slowly but relentlessly. If individuals consistently choose healthier-looking partners, then the traits associated with visible health become more common. Bare skin made these traits easier to notice. And so, humans with less body hair, whose health and conditions could be read more easily, gained an advantage in mating, passing on genes for reduced fur. But attraction didn't only flow through the eyes, it moved through touch. Bare skin is far more sensitive than furred skin. A light brush across the arm, a hand resting on a shoulder, the warmth of two bodies sleeping close together. These sensations deepened bonds. Fur could dull these subtleties, but hairless skin amplified them. Touch became a pathway to emotional connection, comfort, reassurance, and pleasure. Pairs who bonded strongly raised offspring more successfully. Groups that built closer relationships cooperated better and defended one another fiercely. In this way, hairless skin supported social stability, and sexual selection rewarded it. Even more subtle than touch was the role of scent. Areas of the body that retained hair, the armpits, the groin, became zones where pheromones collected and signaled identity, fertility, and emotional state. The contrast between mostly smooth skin and select patches of hair increased the effectiveness of these signals. Hairlessness didn't erase scent communication, it refined it. As human groups spread across different landscapes, preferences evolved with them. In some regions, darker, thicker skin was prized for its protection against sunlight. In others, lighter skin indicated adaptation to lower UV levels. But across all environments, there is evidence that hairlessness consistently aligned with attractiveness, not as a fashion trend, but as a deep-rooted evolutionary preference. Bare skin also improved emotional transparency. Without fur masking the face, micro-expressions became visible. tiny twitches around the eyes, the tension of the jaw, the tremble of the lips, the heat rushing into cheeks during fear or excitement. Being able to read emotions quickly helped humans avoid danger, resolve conflict, and strengthen alliances. Sexual selection rewarded partners who could communicate clearly through expressions, touch, and skin. In time, what had begun as a trait shaped by heat and parasites became reinforced by the powerful pressures of desire. By the era when early humans developed more complex tools and social structures, the loss of fur had acquired a momentum of its own. Even if the environment had cooled, even if parasites had reduced, even if endurance hunting became less central, sexual selection alone could have sustained the trend toward hairless bodies. Hairlessness had become more than a survival advantage. It had become part of what humans found beautiful. As early humans continued to evolve in complex social groups, the influence of sexual selection grew even stronger. What began as small instinctive preferences slowly transformed into widespread patterns, choices repeated generation after generation until they shaped the very anatomy of our species. Bare skin, once simply a byproduct of heat management and parasite avoidance, became woven into the psychology of attraction. The more visible the skin became, the more it shaped how individuals judged potential partners. Smooth, unblemished skin signaled good health in ways fur never could. When two individuals approached each other, they could immediately read signs of sickness, dehydration, injuries, or infections. A subtle rash, a break in the skin, a change in coloration, all these cues provided vital information about a person's fitness. Choosing mates based on these cues became a powerful evolutionary force. Those who selected healthier partners produced healthier offspring, reinforcing the preference for individuals whose bare skin revealed strength rather than weakness. But attraction extended far beyond physiology. Bare skin amplified expressiveness in ways that furred animals could never achieve. The face became a dynamic canvas. Tiny changes, flushes of embarrassment, the warmth of affection, the pallor of fear, gave insight into a person's emotional state. This transparency encouraged honesty, or at least made deception harder. Partners who could read each other's emotions bonded more deeply, trusted one another, and raised offspring with greater cooperation. These stable bonds increased the odds of survival, making emotional readability a trait worth selecting. Touch, too, became a powerful language. A hand resting on a bare arm communicated more than words. Warmth, reassurance, desire, and comfort flowed through contact. Skin-to-skin touch soothed infants, strengthened pair bonds, and created trust within groups. Those who valued touch, and the partners who responded to it, formed stronger relationships. Evolution favored individuals who built these bonds because commitment and cooperation made raising children easier and safer. In this way, bare skin encouraged long-term partnerships, which in turn encouraged the genetic traits that maintained hairlessness. Over time, skin itself became tied to identity and individuality. Without a thick blanket of fur, patterns of pigmentation, scars, freckles, and subtle differences in tone became distinguishing markers. Communities developed aesthetic preferences shaped by their environment. Darker skin provided essential UV protection near the equator and signaled resilience under harsh sunlight. Lighter skin emerged where UV levels were lower, aiding vitamin D production. Within each group, these adaptations influenced what was considered beautiful or desirable. Attraction aligned with health, and health aligned with adaptation. Hair, once a uniform coat covering the entire body, now served specific purposes in select places. Its retreat from the skin made the remaining patches more meaningful. Scalp hair framed the face and protected the brain from overheating. Eyelashes and brows shielded the eyes. Hair in intimate regions intensified scent cues related to fertility, readiness, and hormonal state. These remaining zones became important in mating rituals and attraction, reinforcing the connection between hairlessness in most places and hair in particular ones. As humans developed more tools, shelters, and social networks, sexual selection interacted with culture. In some groups, decorated skin, paint, ochre, tattoos became a form of courtship display. In others, grooming rituals strengthened relationships. Over time, the bare human body became a canvas for storytelling, symbolism, and status. The more visible the skin was, the more it became intertwined with identity, art, and attraction. Bare skin also encouraged social cooperation. Because humans could read emotional states quickly, misunderstandings decreased. People sensed fear in a companion's trembling skin or exhaustion in their posture. Recognizing these cues without words made group hunting, resource sharing, and collective defense more efficient. Groups that cooperated better survived better, and cooperation reinforced the preference for partners whose skin displayed emotions clearly. By the time complex societies began emerging, hairlessness was already deeply rooted in human evolution, not merely a response to climate, parasites, or endurance, but a product of desire, intimacy, and the social brain. Attraction had magnified the trend, ensuring that bare skin remained a dominant trait no matter where humans traveled. Even today, long after clothing replaced fur and technology replaced fire as our primary defense, the legacy of sexual selection lives on. We still interpret tiny changes in skin tone as signals of emotion. We still bond through touch. We still groom ourselves and others. And across cultures, the visibility of skin continues to play a central role in beauty, connection, and identity. What began as a survival adaptation in the savannah became a feature that humans found compelling, expressive, and deeply meaningful, a trait reinforced not only by nature, but by choice. As human bodies grew increasingly bare, they faced a new threat no thick coat of fur had ever fully revealed: the relentless, penetrating power of the sun. Fur had once shielded our ancestors from ultraviolet radiation, softening its impact and deflecting much of its danger. But without that natural covering, human skin stood exposed beneath an equatorial sky that delivered some of the most intense UV radiation on Earth. This exposure created a new evolutionary challenge, one that shaped not only our biology, but the very colors we carry on our skin. Imagine an early human standing on an open plain at noon. The sun hangs high overhead, its light scorching the ground until the air trembles. With fur, much of this light would bounce away. But with bare skin, UV rays strike directly into deeper layers of tissue. Prolonged exposure can break down collagen, damage DNA, cause infections, and, in severe cases, threaten reproductive success. The stakes were high, and evolution responded swiftly. The solution lay in melanin, the pigment that gives skin its color. Melanin is more than a dye. It is a molecular shield, absorbing UV radiation and protecting DNA from mutation. As fur thinned from the limbs, chest, back, and face, natural selection favored individuals with higher melanin concentration. Their darker skin acted like biological armor, reducing the risk of sunburn, infection through damaged skin, and long-term cellular damage. These individuals survived more consistently, reproduced more frequently, and passed on their protective pigmentation. This adaptation did more than prevent surface-level damage. It protected something much more critical: folate. Folate is a nutrient essential for reproduction, fetal development, and cellular repair. UV radiation can break it down rapidly. Individuals with lighter, unprotected skin living under intense sunlight risked folate depletion, leading to birth defects or reduced fertility. Darker skin preserved folate levels, safeguarding the next generation. Through this mechanism, melanin became one of the most important evolutionary innovations in early human history. As early humans spent more time traveling exposed landscapes, tracking prey, gathering resources, migrating between water sources, the value of melanin grew. Dark skin prevented heat lesions, improved resistance to bacterial infections entering through sun-damaged wounds, and shielded the body during long days under punishing sunlight. The advantage was so significant that, for hundreds of thousands of years, nearly all early humans in Africa shared a deep, protective skin tone. This development influenced behavior as well. Groups learned to time their activities around the sun cycle. Morning and late afternoon became prime hours for movement. Midday was reserved for rest, shade, or water. Those with darker skin could tolerate longer periods under the sun and maintain endurance even during hotter seasons. Bare skin and dark pigmentation worked together, allowing humans to expand their territories and endure harsher landscapes. However, melanin did more than protect. It interacted subtly with temperature regulation. Dark skin absorbs more heat than light skin, but because early humans had become efficient at sweating, this was not a disadvantage. The cooling system of the body compensated for heat gain, while the protective benefits of melanin far outweighed any added thermal load. This dynamic shaped social perception too. Within early communities, dark, healthy skin signaled resilience, vitality, and successful adaptation. It showed that an individual could withstand long-distance travel, hunt under the sun, withstand infections, and nurture healthy offspring. Traits tied to survival often became tied to attraction. And once again, sexual selection likely reinforced what natural selection had already begun. Across generations, pigmentation deepened and stabilized as a core component of the bare skin strategy. Fur had once shielded the body from radiation. Now, melanin did the job more efficiently, without blocking the sweat-cooling system that kept humans active. Humans were not simply hairless apes. They were hairless apes engineered for sunlight. But this adaptation also carried a hidden flexibility, one that would dramatically influence human appearance as groups began migrating out of Africa into vastly different climates and sunlight conditions. In lower UV landscapes, the balance between protection and vitamin D production would shift again, leading to one of the most visually diverse evolutionary patterns in our species. For now, early humans in Africa carried the perfect combination: bare skin for cooling and dark pigmentation for protection, a fusion of adaptations that allowed them to thrive under a sun that would have destroyed any other primate stripped of fur. As generations of early humans continued to live under the intense African sun, melanin remained one of their strongest defenses. But human groups were never static. They wandered, sometimes slowly, sometimes in bold waves, across shifting landscapes, looking for new food sources, safer territories, or more predictable seasons. And as they moved into environments where UV radiation varied dramatically, their bare skin met entirely new evolutionary pressures that would diversify the human appearance more than any other trait in our species' history. The first great migration out of Africa brought humans into regions where sunlight wasn't nearly as severe. Skies were often clouded. Winters shortened the days. Much of the energy that once beat down on African savannas simply didn't reach these northern and western territories. Under these dimmer skies, the advantage of having very dark skin began to shift. While dark melanin protected against UV damage, it also reduced the skin's ability to produce vitamin D, an essential nutrient for bone health, immunity, and healthy childbirth. In lower UV regions, individuals with slightly lighter skin could create vitamin D more efficiently. Meanwhile, those with darker pigmentation were more likely to develop deficiencies that weakened bones, increased the risk of fractures, or complicated pregnancies. These challenges didn't kill outright, but they subtly reduced reproductive success. Over many generations, selection favored lighter skin among populations living far from the equator. This shift wasn't immediate. It unfolded slowly, influenced by diet, migration patterns, and the types of shelter groups created. Those who lived near coasts and consumed vitamin D-rich seafood could maintain darker pigmentation longer. Those who settled inland, especially in forested or cloudy regions, benefited more from lighter skin. Instead of a single evolutionary solution, humans developed a spectrum of pigmentation adapted to a spectrum of environments. Bare skin allowed this flexibility to take place quickly. Fur would have masked these changes, forcing the body to rely solely on internal biology. But exposed skin responded directly to sunlight, and even modest pigmentation differences became visible. Over time, local climates sculpted human diversity with remarkable precision. But the story of skin color is not only about sunlight and vitamin D, it also reflects culture. As early communities developed clothing and shelters, individuals spent more time indoors or under cover. Clothing blocked UV radiation, changing how much sunlight reached the skin. Suddenly, pigment levels that worked perfectly for a naked savanna runner became less effective in colder, clothed societies. Lighter skin became advantageous again, not because people needed protection, but because clothing itself had taken over the role of defense. Human migration into high-latitude regions introduced new challenges. Snow reflected sunlight, increasing UV exposure to the eyes while reducing it to much of the body bundled under layers. Darker hair and brows protected vision, while lighter skin optimized vitamin D production wherever sunlight could still reach. Evolution sculpted these traits simultaneously, producing combinations unique to each region. Yet even in regions with low UV, some populations retained darker pigmentation. This was often tied to cultural lifestyle, long-distance migration, limited clothing, or diets rich in vitamin D. Adaptation didn't occur in one direction only. It responded to the complex interplay between sunlight, ecology, behavior, and culture. Meanwhile, muscle, bone, and brain structures continued to evolve alongside skin. A more varied diet enabled by migration affected hormone levels, metabolism, and energy storage, all of which subtly influenced the appearance of skin, hair, and body shape. The further humans traveled, the more diverse they became, and each new climate offered an evolutionary mirror reflecting which traits would thrive. Through all these changes, one thing remained constant. Humans were hairless animals relying entirely on their skin for survival and communication. Pigmentation became the shield fur once provided. Its variations became as crucial to adaptation as endurance and sweat had been in Africa. By the time humans had spread across multiple continents, skin color had become one of the most visible markers of environmental adaptation in the natural world. But beneath every shade, light, dark, or in between, lay the same evolutionary story. A species that lost its fur and replaced it with something far more dynamic. Soon, another theory, controversial yet compelling, would attempt to explain human hairlessness from an entirely different angle: water. Long before scientists fully understood the roles of heat, endurance, parasites, and sunlight in shaping human hairlessness, a bold and unconventional idea emerged, one that suggested the story might have unfolded near water. This idea, known as the aquatic ape theory, proposed that early humans underwent a semi-aquatic phase that influenced several unusual features of our biology, including the loss of fur. Although debated heavily in scientific circles, this theory remains intriguing because it highlights a set of human traits that appear more aquatic than terrestrial. Imagine early humans living near shallow lakes, marshes, river deltas, or coastal regions where food was abundant. Shellfish, roots softened in water, reed beds hiding small animals, and fish trapped in tidal pools. Many hominins likely spent large parts of the day wading, searching for edible plants, overturning stones, reaching into muddy banks for crustaceans. In environments like these, thick fur would have been a disadvantage. Wet fur becomes heavy, cold, and slow to dry. Bare skin, by contrast, dries quickly and allows heat to escape more efficiently after exertion. Advocates of the theory point to parallels with other semi-aquatic mammals. Animals that spend significant time in water, like hippos, elephants, and pigs, tend to have sparse fur or hairless patches. Their skin thickens or develops protective oils, freeing them from the burden of a heavy, sodden coat. Humans, with their relatively hairless bodies and layers of subcutaneous fat, seem to share some superficial similarities with these species. This raised an interesting question. Could early humans have adapted to watery landscapes in ways that influenced their loss of fur? Supporters argue that several human traits align with this idea. Our ability to voluntarily control breathing is rare among land animals, but common in diving mammals. The position of our nostrils, the shape of our noses, and even the reflex infants display when placed in water, a reflex that causes them to hold their breath and open their eyes underwater, are cited as hints of a semi-aquatic past. While none of these features prove the theory, they paint a picture of a species surprisingly comfortable around water. Bare skin may have offered advantages in such environments. In water, hair does little to regulate temperature. Instead, fat does. Humans possess a continuous layer of subcutaneous fat, far more similar to marine mammals than to other primates. This fat provides buoyancy and insulation, allowing early humans to swim or float with relative ease. It also plays a role in energy storage and thermal regulation, making the body more resilient to cold conditions one might encounter in lakes and rivers. Even our sweat glands fit into this aquatic puzzle. While sweating is primarily a terrestrial adaptation for cooling, some theorists suggest that early humans who moved between land and water needed skin capable of managing rapid temperature shifts. Bare skin with dense sweat glands might have allowed them to regulate heat efficiently when transitioning from swimming or wading to walking under the sun. Another point often raised is human newborns. Compared to other primates, human infants have more body fat and less fur. They float better, cry loudly, a behavior useful for locating a baby in water, and exhibit reflexes that mimic swimming motions. While these similarities don't prove an aquatic origin, they sparked curiosity about whether our ancestors spent more time in wetlands than previously believed. Still, the aquatic ape theory remains controversial. Most anthropologists argue that the fossil record doesn't support a prolonged aquatic stage. Yet, even without solid evidence, the idea persists because it captures aspects of human anatomy that traditional explanations sometimes overlook. It invites us to imagine early humans exploring not just grasslands and forests, but riverbanks and coastlines, environments rich with food and shelter but demanding new adaptations. Whether or not humans ever lived as semi-aquatic creatures, the theory highlights a fundamental truth. Our bodies contain mysteries that cannot always be explained by a single force. Hairlessness may have multiple origins, layered over one another through millions of years of survival. But the aquatic hypothesis doesn't stand alone. If this idea sparks debate, the reasons for scientific resistance reveal just as much about how humans truly evolved and why most experts believe the loss of fur can be explained more convincingly by other pressures. Despite its imaginative appeal, the aquatic ape theory has always lived in a space between fascination and skepticism. While it offers a dramatic narrative, humans wading through wetlands, diving for food, evolving sleek bodies suited for water, most anthropologists hesitate to accept it as the primary explanation for hairlessness. Yet understanding why the theory is debated is just as important as understanding the traits it tries to explain. For one, the fossil record tells a different story. Most early human fossils are found far from ancient coastlines or deltas. They lived in savannas, mixed woodlands, and open grasslands, not in environments that would force a semi-aquatic lifestyle. Stone tools, animal bones with cut marks, and ancient fire sites suggest hunting, butchering, and endurance-based foraging, not marine-based diets. If humans had undergone a long aquatic phase, we would expect skeletal features explicitly shaped by swimming or diving, but such traits don't appear in the bones we've recovered. Another challenge lies in timing. The loss of fur appears to have begun around the same period humans became superb distance runners, long before any evidence suggests extensive aquatic behavior. Sweating, the most efficient cooling method we possess, is a disadvantage in water because it doesn't function there at all. If humans had adapted primarily to aquatic life, natural selection might have favored waterproofing, insulating fur, or thicker skin, traits seen in beavers or otters, not the sweat-heavy, water-permeable skin we have today. Even the presence of subcutaneous fat, often cited as aquatic evidence, fits better with a terrestrial endurance lifestyle. Long-distance runners and migrating animals rely on fat reserves for sustained energy, and early humans who traveled vast ranges or endured long hunts would have needed reliable, portable fuel. Fat also helps insulate heat produced during extended exertion. In this context, it becomes less of a sign of aquatic ancestry and more of a reflection of our terrestrial athleticism. Still, the aquatic theory does highlight real questions about our anatomy. Why are humans almost entirely hairless, while every other primate is coated in dense fur? Why does our skin wrinkle in water more dramatically than that of most land mammals? Why are we such proficient swimmers, despite not being truly designed for it? These puzzles add texture to the debate. And although most scientists believe the answers can be explained through heat, endurance, and social factors, the aquatic hypothesis reminds us that evolution is rarely shaped by a single force. Some anthropologists propose a middle path, not that humans were aquatic apes, but that water played an important supporting role in our development. Rivers and lakes offered resources that could complement hunting and gathering. Humans may have waded regularly, collected shellfish, and used water to escape predators or cool down. These behaviors wouldn't require drastic anatomical changes, but over time, they could reinforce the loss of fur initiated by other pressures. Wet fur is inconvenient and slow to dry, while bare skin is efficient both on land and in water. In this hybrid model, the aquatic theory becomes a piece of the puzzle, rather than the entire picture. Water also shaped early human cognition. Watching ripples, predicting currents, recognizing fish movement, learning to dive, these skills demanded observation, coordination, and memory. Even if humans never became truly aquatic, interacting with water may have honed senses that later expanded into more complex problem-solving. And because early humans were explorers by nature, any environment offering food or safety, even temporarily, could influence the direction of their evolution. Where the theory falls short is in explaining the full suite of traits tied to hairlessness. Endurance running accounts more convincingly for sweat glands. Parasite pressure explains the reduction of dense body hair. Fire usage clarifies the decreasing need for insulation. Sexual selection explains the preference for smoother skin. Together, these factors present a far more cohesive and evidence-backed explanation than a long aquatic phase. Yet the aquatic ape theory remains culturally influential because it challenges our assumptions. It asks us to imagine our ancestors in unfamiliar settings. It highlights how traits can emerge from unexpected pressures. And it underscores the fact that human evolution is not a straightforward march, but a tangled path of possibilities, some taken, others abandoned. Whether humans ever waded their way through an evolutionary detour or not, the theory helps illuminate what makes our bodies so unusual among primates. And by examining why it both excites and troubles scientists, we gain a clearer understanding that hairlessness is not the result of a single evolutionary story, but a tapestry woven from many. Ahead lies another piece of that tapestry, the incredible transformation of human skin into a super organ arguably the most advanced biological cooling system in the mammalian world. Long before scientists fully understood the roles of heat, endurance, parasites, and sunlight in shaping human hairlessness, a bold and unconventional idea emerged, one that suggested the story might have unfolded near water. This idea, known as the aquatic ape theory, proposed that early humans underwent a semi-aquatic phase that influenced several unusual features of our biology, including the loss of fur. Although debated heavily in scientific circles, this theory remains intriguing because it highlights a set of human traits that appear more aquatic than terrestrial. Imagine early humans living near shallow lakes, marshes, river deltas, or coastal regions where food was abundant. Shellfish, roots softened in water, reed beds hiding small animals, and fish trapped in tidal pools. Many hominins likely spent large parts of the day wading, searching for edible plants, overturning stones, reaching into muddy banks for crustaceans. In environments like these, thick fur would have been a disadvantage. Wet fur becomes heavy, cold, and slow to dry. Bare skin, by contrast, dries quickly and allows heat to escape more efficiently after exertion. Advocates of the theory point to parallels with other semi-aquatic mammals. Animals that spend significant time in water, like hippos, elephants, and pigs, tend to have sparse fur or hairless patches. Their skin thickens or develops protective oils, freeing them from the burden of a heavy, sodden coat. Humans, with their relatively hairless bodies and layers of subcutaneous fat, seem to share some superficial similarities with these species. This raised an interesting question. Could early humans have adapted to watery landscapes in ways that influenced their loss of fur? Supporters argue that several human traits align with this idea. Our ability to voluntarily control breathing is rare among land animals, but common in diving mammals. The position of our nostrils, the shape of our noses, and even the reflex infants display when placed in water, a reflex that causes them to hold their breath and open their eyes underwater, are cited as hints of a semi-aquatic past. While none of these features prove the theory, they paint a picture of a species surprisingly comfortable around water. Bare skin may have offered advantages in such environments. In water, hair does little to regulate temperature. Instead, fat does. Humans possess a continuous layer of subcutaneous fat, far more similar to marine mammals than to other primates. This fat provides buoyancy and insulation, allowing early humans to swim or float with relative ease. It also plays a role in energy storage and thermal regulation, making the body more resilient to cold conditions one might encounter in lakes and rivers. Even our sweat glands fit into this aquatic puzzle. While sweating is primarily a terrestrial adaptation for cooling, some theorists suggest that early humans who moved between land and water needed skin capable of managing rapid temperature shifts. Bare skin with dense sweat glands might have allowed them to regulate heat efficiently when transitioning from swimming or wading to walking under the sun. Another point often raised is human newborns. Compared to other primates, human infants have more body fat and less fur. They float better, cry loudly, a behavior useful for locating a baby in water, and exhibit reflexes that mimic swimming motions. While these similarities don't prove an aquatic origin, they sparked curiosity about whether our ancestors spent more time in wetlands than previously believed. Still, the aquatic ape theory remains controversial. Most anthropologists argue that the fossil record doesn't support a prolonged aquatic stage. Yet, even without solid evidence, the idea persists because it captures aspects of human anatomy that traditional explanations sometimes overlook. It invites us to imagine early humans exploring not just grasslands and forests, but riverbanks and coastlines, environments rich with food and shelter but demanding new adaptations. Whether or not humans ever lived as semi-aquatic creatures, the theory highlights a fundamental truth. Our bodies contain mysteries that cannot always be explained by a single force. Hairlessness may have multiple origins, layered over one another through millions of years of survival. But the aquatic hypothesis doesn't stand alone. If this idea sparks debate, the reasons for scientific resistance reveal just as much about how humans truly evolved and why most experts believe the loss of fur can be explained more convincingly by other pressures. Despite its imaginative appeal, the aquatic ape theory has always lived in a space between fascination and skepticism. While it offers a dramatic narrative, humans wading through wetlands, diving for food, evolving sleek bodies suited for water, most anthropologists hesitate to accept it as the primary explanation for hairlessness. Yet understanding why the theory is debated is just as important as understanding the traits it tries to explain. For one, the fossil record tells a different story. Most early human fossils are found far from ancient coastlines or deltas. They lived in savannas, mixed woodlands, and open grasslands, not in environments that would force a semi-aquatic lifestyle. Stone tools, animal bones with cut marks, and ancient fire sites suggest hunting, butchering, and endurance-based foraging, not marine-based diets. If humans had undergone a long aquatic phase, we would expect skeletal features explicitly shaped by swimming or diving, but such traits don't appear in the bones we've recovered. Another challenge lies in timing. The loss of fur appears to have begun around the same period humans became superb distance runners, long before any evidence suggests extensive aquatic behavior. Sweating, the most efficient cooling method we possess, is a disadvantage in water because it doesn't function there at all. If humans had adapted primarily to aquatic life, natural selection might have favored waterproofing, insulating fur, or thicker skin, traits seen in beavers or otters, not the sweat-heavy, water-permeable skin we have today. Even the presence of subcutaneous fat, often cited as aquatic evidence, fits better with a terrestrial endurance lifestyle. Long-distance runners and migrating animals rely on fat reserves for sustained energy, and early humans who traveled vast ranges or endured long hunts would have needed reliable, portable fuel. Fat also helps insulate heat produced during extended exertion. In this context, it becomes less of a sign of aquatic ancestry and more of a reflection of our terrestrial athleticism. Still, the aquatic theory does highlight real questions about our anatomy. Why are humans almost entirely hairless while every other primate is coated in dense fur? Why does our skin wrinkle in water more dramatically than that of most land mammals? Why are we such proficient swimmers despite not being truly designed for it? These puzzles add texture to the debate. And although most scientists believe the answers can be explained through heat, endurance, and social factors, the aquatic hypothesis reminds us that evolution is rarely shaped by a single force. Some anthropologists propose a middle path, not that humans were aquatic apes, but that water played an important supporting role in our development. Rivers and lakes offered resources that could complement hunting and gathering. Humans may have waded regularly, collected shellfish, and used water to escape predators or cool down. These behaviors wouldn't require drastic anatomical changes, but over time, they could reinforce the loss of fur initiated by other pressures. Wet fur is inconvenient and slow to dry, while bare skin is efficient both on land and in water. In this hybrid model, the aquatic theory becomes a piece of the puzzle, rather than the entire picture. Water also shaped early human cognition. Watching ripples, predicting currents, recognizing fish movement, learning to dive, these skills demanded observation, coordination, and memory. Even if humans never became truly aquatic, interacting with water may have honed senses that later expanded into more complex problem-solving. And because early humans were explorers by nature, any environment offering food or safety, even temporarily, could influence the direction of their evolution. Where the theory falls short is in explaining the full suite of traits tied to hairlessness. Endurance running accounts more convincingly for sweat glands. Parasite pressure explains the reduction of dense body hair. Fire usage clarifies the decreasing need for insulation. Sexual selection explains the preference for smoother skin. Together, these factors present a far more cohesive and evidence-backed explanation than a long aquatic phase. Yet the aquatic ape theory remains culturally influential because it challenges our assumptions. It asks us to imagine our ancestors in unfamiliar settings. It highlights how traits can emerge from unexpected pressures. And it underscores the fact that human evolution is not a straightforward march, but a tangled path of possibilities, some taken, others abandoned. Whether humans ever waded their way through an evolutionary detour or not, the theory helps illuminate what makes our bodies so unusual among primates. And by examining why it both excites and troubles scientists, we gain a clearer understanding that hairlessness is not the result of a single evolutionary story, but a tapestry woven from many. Ahead lies another piece of that tapestry, the incredible transformation of human skin into a super organ, arguably the most advanced biological cooling system in the mammalian world. As humans shed their ancestral fur, the exposed skin beneath it wasn't merely revealed, it began to transform. What had once been a hidden layer under dense hair evolved into one of the most versatile, expressive, and powerful organs in the natural world. Human skin became more than protection. It became technology, an adaptive system that balanced cooling, communication, sensation, and survival in ways no other primate could match. With the retreat of fur, sweat glands were no longer obstructed. This freed them to function at their absolute peak, covering nearly every inch of the body. Human skin became a living radiator, capable of shedding heat faster than that of any other mammal. Imagine a group of early humans trekking under the midday sun, their exposed skin glistening as sweat evaporated in the hot wind. Their bodies stayed cool even as they walked for hours. This ability allowed them to cross vast plains that would have overwhelmed any fur-bearing predator or prey. But the skin did more than release heat. It sensed the world with incredible precision. Without fur dulling contact, every shift in temperature, every change in humidity, every brush against grass or stone became instantly noticeable. This heightened sensitivity warned of danger, sharp thorn, biting insect, sudden chill, and guided movement through dense terrain. Touch became not only protective but informative, giving humans the ability to navigate darkness, feel vibrations through the ground, and maintain balance during long-distance travel. The skin also became a crucial communication tool. Expressions that were once partially hidden beneath fur now stood unconcealed. A blush racing across the cheeks, a flush of anger, the pallor of fear. Emotions that might have been subtle became visible, allowing others to interpret mood and intention instantly. This emotional transparency forged deeper trust within groups. When danger approached, the tension in someone's face warned the rest. When joy spread through the camp, everyone saw it reflected in bare expressions. Bare skin also amplified the power of touch in social bonding. Grooming, once focused on removing parasites from fur, shifted into more intimate forms of contact, gentle brushing, skin-to-skin comfort, soothing gestures that strengthened cooperative relationships. Touch became a universal language, especially for infants who relied on warmth and contact for their earliest understanding of safety. As groups grew larger and more complex, skin played a role in recognizing individuals. Patterns of pigmentation, scars from hunts, freckles from sun exposure, and the textures formed by age gave every person a unique appearance. These natural markers helped groups track identity, memory, and lineage. Even before names existed, skin told stories. Where someone had traveled, what hardships they had endured, what role they played in the group. Losing fur also allowed humans to manipulate their appearance in ways no other primate could. They decorated their bodies with ash, clay, plant dyes, and eventually pigments. These markings weren't simply decorative. They could signify rank, warn predators, strengthen group unity, or prepare warriors psychologically for conflict. The human body became a canvas long before it became clothed. Skin's importance only grew as humans mastered fire. Heat from flames warmed exposed flesh, allowing them to inhabit cooler regions. Smoke protected their skin from insects. Ash soothed irritation and masked scent while hunting. Without fur, these benefits acted directly on the skin's surface, making adaptation even more effective. But one of the most remarkable changes occurred beneath the surface. Sweat glands evolved not only in number but in function. They produced a watery secretion ideal for cooling, but they also played roles in scent communication. Bare skin, catching the breeze, carried subtle chemical signals that revealed stress, fear, readiness, or illness. These signals guided behavior within the group and influenced decisions during mating, conflict, or exploration. Thermoregulation, communication, sensory precision, emotional expression. Human skin was becoming a superorgan. Its adaptability allowed humans to operate in a wider variety of climates than any primate before them. This transformation laid the foundation for migrations into deserts, mountains, and eventually regions far beyond Africa. But the evolution of skin wasn't finished. As humans continued to build societies, form alliances, raise families, and hunt together, their bare skin took on a new role, not only a tool for cooling and sensing, but a crucial element of social life itself. As human skin grew into a powerful biological tool, its influence extended far beyond physiology. It became essential to social structure, emotional intelligence, cooperation, and the shared identity that bound early humans together. While fur-covered animals relied on vocalizations or scent alone, humans carried a complex network of signals directly on the surface of their bodies. Signals that shaped relationships, resolved conflicts, and strengthened the foundations of community life. Bare skin made emotional expression immediate and visible. A flush of embarrassment, the pallor of fear, the heat of anger rising under the cheeks. These subtle shifts told others exactly what someone felt in the moment. No other primate displayed its emotions so openly. This transparency reduced misunderstandings within groups. When a hunter returned exhausted, his skin showed it. When someone sensed danger, their tension was visible before a sound was made. When anger brewed, it could be recognized early and diffused. These cues formed a silent language, one that helped early humans cooperate with remarkable efficiency. Touch deepened these bonds further. Without fur, skin-to-skin contact became one of the most powerful ways to build trust. A reassuring hand on the back, a mother holding her child close, a pair resting against each other for warmth. All of these gestures strengthened group cohesion. Infants who experienced more touch developed stronger emotional regulation and bonded more deeply with caregivers. Adults who trusted one another moved more effectively as a team during hunts, migrations, and conflicts. Touch became a glue that held early societies together. Bare skin also reshaped how humans viewed one another. Patterns of pigmentation, scars, and the texture of skin offered clues to a person's health, age, and life experiences. A scar across the forearm might tell of a successful hunt or a narrow escape. Calloused hands hinted at long journeys or skilled craftsmanship. Sun-darkened skin revealed time spent outdoors. These markings allowed individuals to read each other's histories at a glance. Over time, this strengthened the role of reputation, storytelling, and personal identity. Clothing and body decoration amplified these signals. As humans learned to mark their skin with ochre, charcoal, and clay, they gained new forms of expression. Painted patterns could designate roles: hunters, healers, elders, or leaders. Designs could intimidate enemies or unite warriors before a hunt. Ritual markings strengthened group identity, turning bare skin into a canvas for cultural meaning. Unlike fur, which concealed the body, skin offered a surface that humans could shape according to tradition, status, or belief. These evolving social dynamics allowed humans to live in larger, more cooperative groups than any primate before them. Cooperation became essential for survival. Coordinated hunting, shared childcare, collective defense, and knowledge transmission. Bare skin helped make cooperation smoother by revealing emotion, encouraging touch, and allowing rapid interpretation of social cues. It helped build empathy, an understanding of others' internal states simply by observing their bodies. Skin's sensitivity also shaped human behavior. The pleasure of warmth from a fire, the cooling sensation of water, the comfort of touch, and the excitement of proximity all had emotional consequences. These sensations influenced decision-making, attachment, and even rituals. Gatherings around fire became central to social life, and bare skin glowed in the shifting light, making expressions more noticeable and gestures more meaningful. The night, once a time of fear, became an intimate shared space where bonds deepened. Even pain played a role. A cut or burn was immediately visible, allowing others to react quickly, help cleanse wounds, or prevent infection. In social animals, visible injury often changes group dynamics, but in early humans, the ability to treat and protect the wounded strengthened social trust. It taught empathy and reinforced the idea that helping others increased the chances of group survival. Bare skin, in this way, wasn't merely an adaptation to heat or parasites. It became a medium through which early humans understood one another. It played a central role in the development of cooperation, empathy, and emotional intelligence, traits that would eventually lead to language, culture, and complex societies. The human body was evolving not just physically, but socially, and this transformation set the stage for one of the great evolutionary distinctions between humans and their closest relatives. Why we, alone among primates, lost our fur while chimpanzees, gorillas, and orangutans kept theirs. As humans evolved into nearly hairless beings, one question lingered like a shadow over our evolutionary story. Why didn't other primates follow the same path? Chimpanzees, gorillas, orangutans, our closest relatives, remain covered in dense fur, living lives shaped by the same ancestral blueprint humans once shared. Understanding why they kept their coats reveals not only what makes us unique, but how profoundly our ancestors diverged from the primate destiny. For millions of years, most primates thrived in environments where fur offered powerful advantages. Dense forests shielded them from direct sunlight. The canopy filtered harsh UV rays, keeping temperatures stable and humidity high. In these shadowed worlds, a thick coat acted as natural insulation. It protected against cool nights, sudden rain, biting insects, and the friction of climbing. There was simply no reason to lose it. Gorillas and chimpanzees still live in similar conditions today. Their days are spent under trees or among dense vegetation where heat is moderated. When they move, they do so in bursts, short sprints, climbs, leaps, not the marathon-like endurance humans rely on. Their bodies don't face hours of relentless exertion under open skies. They don't need to dissipate internal heat created by long-distance running. Instead, fur remains the optimal design, keeping them warm during cool dawns and protecting them during nights spent on branches or nests of leaves. Another crucial difference lies in locomotion. Non-human primates are quadrupeds. Their bodies align horizontally, exposing their backs, but not their chest and abdomen to the sun. Efficient panting cools them as they move. Panting works well for short bursts of activity, especially when the body isn't generating tremendous internal heat. For gorillas and chimps, whose days revolve around foraging, socializing, climbing, and occasional territorial displays, panting remains an effective cooling system. They had no evolutionary pressure to trade fur for sweat. Their social structures also played a role. Most primates live in smaller groups than early humans eventually did. While grooming is important for bonding, their lower group densities reduce the rapid spread of parasites that plagued early human camps. Fur, in their environment, remains a manageable habitat for insects, and because these primates rarely sleep on the ground, preferring trees or raised nest platforms, they avoid many ground-dwelling parasites that tormented fur-covered early humans. Fire, a human innovation that changed everything, never entered their evolutionary story. Without fire, no external source of warmth existed to replace fur's insulation. Nights in the forest can be surprisingly cold, and primates rely heavily on their coats to maintain body temperature. Even today, chimpanzees and orangutans build nests at dusk, layering branches and leaves to trap heat along with their fur. Gorillas huddle close during mountain cold spells, their thick coats acting as shields. Without cultural tools like fire or clothing, fur remained essential. Diet provided yet another layer of distinction. Great apes rely heavily on plants, fruits, and raw vegetation. These diets provide less fat and fewer calories compared to the meat-rich diet humans gradually adopted. A leaner, more plant-based diet doesn't support the same type of energy-intensive lifestyle humans developed, one that required long pursuits, extensive travel, and high levels of internal heat production. Because their metabolisms and activities remained moderate, they didn't evolve the need for large-scale sweating or fur reduction. And perhaps most telling of all, other primates never made the leap that ultimately changed the direction of human evolution. Full-time bipedalism. Standing upright exposed the entire torso directly to the sun. Running long distances forced the body into extreme thermal stress. Endurance hunting demanded the most efficient cooling system evolution could provide. Humans were thrust into an arena where fur became a liability. Other primates remained where fur was still king, yet the difference wasn't simply environmental, it was behavioral. Humans changed how they slept, moved, hunted, and interacted. These changes stacked upon one another, creating a cascade of evolutionary pressures that fur-bearing primates never experienced. Chimps didn't chase prey for hours, gorillas didn't migrate across open plains, orangutans didn't gather in large ground-based camps. Their worlds remained stable, shaded, and insulated. Ours became exposed, mobile, cooperative, and increasingly bound to fire and open landscapes. In essence, humans diverged because we stepped out of the forest and never looked back. The world that shaped us was fundamentally different from the one that shaped our primate cousins. Where they found continuity, we found change. Where they preserved ancient adaptations, we abandoned them. And where they stayed within the protective arms of the canopy, we chose the blazing horizon. This divergence led to one of the most extraordinary chapters of human evolution, the moment when the naked ape stepped fully into its own identity, no longer resembling the creatures it had once lived among. As humans continued evolving into a nearly hairless species, the gap between our bodies and those of other primates widened, not through a sudden break, but through millions of small decisions shaped by behavior, environment, and survival strategies. To understand why chimpanzees, gorillas, and orangutans still carry thick coats of fur, we must look deeper into the forces that kept their evolutionary paths stable, while ours diverged drastically. One of the most important factors is lifestyle. Non-human primates rarely travel long distances. They live in territories where food is often abundant and close at hand. Gorillas feed on leaves and shoots that grow everywhere around them. Chimpanzees forage for fruit, insects, and occasional meat within a limited range. Orangutans drift from tree to tree in dense forests rich with fruit clusters. Their movements involve bursts of energy, but not the sustained exertion that generates massive internal heat. Without this constant internal heat buildup, evolution had no reason to strip away their fur. A thick coat remained useful, not restrictive. Their predators, and their strategies against them, also remained different. Most primates evade danger by ascending into trees. An approaching leopard or pack of wild dogs sends them scrambling upward, where dense fur protects their bodies from rough bark and snapping branches. Heat buildup is never the pressing concern. Immediate flight is. Humans, by contrast, adapted to the ground. Standing upright, endurance-based movement and coordinated group defense replaced arboreal escape. As humans confronted predators on open plains, the evolutionary balance shifted toward cooling ability, not climbing agility. Another stabilizing force was the absence of fire. Without fire, primates depend on the environment, not tools, to regulate body temperature at night. Forest nights can be surprisingly cold. In mountain habitats where gorillas live, temperatures drop sharply after sunset. Their dense fur becomes essential for warmth. Even chimpanzees in warm climates depend on fur as a nighttime blanket while resting in nests high above the ground. Since they never adopted fire as a cultural technology, thick fur remained their primary survival mechanism. Fire also changed human behavior in ways primates never mirrored. Humans slept on the ground, gathered around flames, and eventually built shelters that trapped heat. With these cultural tools, humans no longer relied on fur for insulation. Other primates never made this leap. Without external heat sources, they remained biologically dependent on their coats. Parasites represent another dividing line. While humans reduced parasite loads through fire, grooming, and ground-based shelters, other primates maintained fur in environments where grooming alone was sufficient. Living in smaller groups, often spread across forest canopies, they avoided the dense, ground-level parasite exposure humans experienced in savanna environments. Their grooming rituals remained effective, and fur continued to serve as both protection and a social bonding tool. In their ecosystems, fur did not create overwhelming parasite burdens. In humans' ecosystems, it did. We must also consider that primates evolved under much more stable environmental conditions. Their habitats changed, but not with the same scale or frequency that shaped early human landscapes. The savanna expansion, climate fluctuations, and shifting migratory routes pushed humans into new adaptive pressures over and over. Primates, sheltered by forest ecosystems, did not face the same environmental upheaval. Evolution rewards stability where stability works, and primate fur remained a successful design for millions of years. Even human brain evolution played a role in this divergence. As humans developed larger brains, more advanced social systems, and intricate cooperation, they created cultural solutions that replaced biological ones. Clothing, fire, tools, and shelters allowed them to survive environments far beyond what their bodies alone could handle. Other primates, lacking cultural technology of this scale, remained biological creatures first and foremost. Their survival depended on bodies shaped by slow evolutionary adaptation, not by innovation. Finally, sexual selection in primates reinforced fur rather than eroding it. In many species, thick, healthy fur signals vitality, fertility, and dominance. A male mandrill's coat, a silverback gorilla's impressive mass of hair, or the shine of an orangutan's fur all communicate reproductive fitness. In humans, attraction favored bare skin. In other primates, it preserved thick coats. These preferences, repeated across thousands of generations, tightly locked their fur patterns in place. In short, other primates kept their fur because their worlds never demanded they lose it. Their cooling systems remained effective. Their environments favored insulation. Their social and reproductive signals were tied to fur. Their nights were cold, their predators fast, their habitats shaded, their technologies limited. Humans, on the other hand, were propelled into a new evolutionary landscape, one that rewarded hairlessness at every turn. This divergence, slow, steady, and guided by countless pressures, set the stage for the final transformation of our species, the moment we fully emerged as the naked ape, shaped not only by nature, but by the choices and innovations that defined who we would become.